Again, I want to welcome everyone. Excited to see everyone. January 2022, IndiePie. I agree with Laura's sentiment on this slide. Here for 7 p.m. Seems like that time works really well for folks to getting back in person. Want to make sure you all follow us on Twitter, the @IndiePie user, or using the IndiePie hashtag. So feel free to live tweet this tonight's session. I think actually Laura will be probably live tweeting as we go. So you feel free to jump on there, follow IndiePie, and reply and join in that conversation. Make sure you're registered for tonight's event, and also that you register through meetingplace.io for all the RSVPs. We've moved off of Meetingplace or Meetup.com. I want to thank our sponsors this evening, and we actually have got 4 sponsors we're going to mention tonight. So it's a cool place to be if you want to make sure you're sponsoring like the fun meetup groups. Make sure you're sponsoring IndiePie. I want to thank 6 Feet Up, who is actually a company that I helped co-found. So IndiePie is brought to you by 6 Feet Up. 6 Feet Up is a software company that helps organizations build apps faster, innovate with AI, simplify big data, and leverage cloud technology. I co-founded 6 Feet Up in 1999. I've been the CTO ever since. I want to thank JetBrains for providing us with some of our door prizes this evening. So stick around after our presentation. We will do a door prize drawing. We will give away a couple JetBrains PyCharm professional licenses. I want to thank them for being a long-time sponsor now of IndiePie. And then our bronze sponsors. JFrog will be giving away a Adafruit Clue. I think they're still doing the Clue. So they're going to give away a piece of hardware. And then Reify Health, actually, Jeff is here. So Jeff, do you want to give a quick little intro to Reify?
I would love to. Thank you so much, Calvin. You guys can hear me okay?
Yeah, absolutely. No, it's perfect.
Good. First of all, thank you, Laura. Thank you, Calvin, for giving me the chance to be here with, like you said, Calvin, the cool meetup group, and giving Reify Health a little bit of airtime. Just a quick note, we're super proud to sponsor both IndiePie and AWS. So if you come next week, you might have the opportunity to hear me again. Yay. But just a very quick blurb about Reify Health. We are a Boston-based SaaS company, but we are 100% remote. We have a very healthy Series C round of investment last year that allowed us to go from 26 software engineers at the start of 2021 to 127 engineers. We did all that through organic hiring, and we're poised to hire another 100 engineers this year. So lots of careers in Python, in Clojure, in React, TypeScript. We're fully AWS native with 6 regional deployments that are multi-tenant worldwide. So just a quick note on the careers page. I don't have PyCharm licenses or cool raffle things, but maybe there's some new career opportunities we can offer. But
that's great.
Very mission driven. Please, I encourage you to check out our website as we look to help make clinical trials better and bring greater things to humans through the higher success rate and speedier execution of clinical trials. So thanks again, Calvin. Thank you for Laura, and back to you guys.
Awesome. Thanks, Jeff. Thanks for being a sponsor. I think communities love having organizations get engaged like that. So we're glad you're here. All right. So speaking of being a sponsor, if you too would love to share the spotlight here on the IndiePie platform, make sure you go to that URL, or you can just email Laura directly, and she would be happy to get you hooked up as a sponsor. We use that money to do awesome programs and basically extend the message that we can do with IndiePie. Obviously, when we're back in person, it's easier to give you all folks things, but we want to make sure we can still do other kinds of programs, and that's where the sponsorship dollars go. They're going towards us being a part of the community, helping sponsor the Python Software Foundation, doing things like that. So that's where you can sponsor. Speaking of jobs, if you go to our Slack, so there's an IndiePie Slack, that is a inviter link right there. You should be able to get dropped right into the IndiePie Slack. There is a jobs channel in that Slack. So if you are hiring, I encourage you to go post your job listings there. And if you are looking for a career change, please post in there as well. Tell us what you're looking for. Tell us the kind of skills you've got. And we want to make sure people get hooked up with great opportunities, and hopefully through IndiePie. I mentioned it before, but we have moved to meetingplace.io. when I do the drawing for our door prizes this evening after our speaker, to be eligible for that drawing, make sure you are RSVP'd over on meetingplace.io, because I will do a live drawing where I will scrape the RSVPs directly from the site, and we'll do a little Python live code to choose the winner. But you must be RSVP'd, so preferably before the speaker ends their talk this evening, if you want to be considered for our door prizes. And it's also, that's our official RSVP place for all things IndiePie. With all that being said, I don't think I've missed anything, and I will make sure we're back after our speaker to do the door prize drawing. Oh, we've got not just 2 PyCharm licenses, we've got 4 PyCharm licenses this evening. Stick around. There's a good chance you may end up with a PyCharm professional license or a native fruit clue. So with that all being said, I'm going to stop my screen share. I'm going to let Rocco take over, because you aren't here to talk to me. You're here to talk to Rocco.
Thank you, Calvin. And thank you, everybody, for joining tonight. It's great to see everyone here. My name is Rocco Pascale. I am a field engineer at Astronomer. So what I do is a lot of demonstrations. I work with potential customers during the sales cycle through different types of evaluations. Before joining Astronomer, I was a data engineer at a variety of organizations utilizing Apache Airflow. And since I've joined Astronomer, I've also got the opportunity to contribute to the project, which has been really great. So as we'll learn tonight, Apache Airflow is an open source project written in Python. So, definitely how I've changed. Instead of playing video games, I've now moved to contributing open source software. All right. Well, again, thank you everyone for joining tonight for an introduction to Apache Airflow. And what we'll do now is we'll go into our agenda. So we'll answer the obvious question, what is Apache Airflow? We'll dive into some core principles and how Airflow is used in practice. From there, we'll go into some of the core concepts, which are some of the fundamental components of Airflow, which are dags, tasks, and operators. We'll then go into how we can use this rich framework to meet different types of scheduling strategies and different types of dependencies you may have in your workflow, and how you can tune the knobs of Airflow to match that. We'll then go into how you can connect to external services that you're orchestrating with Airflow, and how Airflow will provide first-class support for that type of framework. Then we'll go into what is known as XCOM, which is how different tasks can communicate between each other. Again, Airflow providing that ability for independent processes to persist information across your process. With all this information, we'll go into a demonstration and code review and see all of it in action. And again, during that time, if you have particular questions or functionality you'd like to see, we could definitely treat that pretty fluidly. Once we have all this information, what I'd like to do then is take a step back and talk about how Airflow is running and the core services and components that power it. And then as well as how you can get started from this presentation, how you can, in the next hour or tomorrow, get Airflow up and running and try testing it out. So what is Apache Airflow? Apache Airflow is a way to programmatically author, schedule, and monitor your data pipelines, written in Python. It was created in the late end of 2014 by a software engineer named Max Beauchamp at Airbnb. And then it was brought to the Apache Software Foundation's incubator program at the late 2016 and continued to see success. By the beginning of 2019, Airflow was announced as a top-level Apache project by the foundation and is now considered one of the leading workflow orchestration solutions available today. So going into some of those core principles, in my experience working with a lot of different technologies, setting a strong foundation for any framework or product is really critical to its longevity and success. And Airflow is built on what I have found and thought to be really, principles that will help it sustain its popularity and usability. So again, its ability to be flexible. You programmatically define your workflows using Python. Its extensibility. The way I like to describe it is if there is an SDK or an API, you can likely extend Airflow with Python to integrate and orchestrate that service. Open source, again, being able to dive into the code to understand how it works, how you may need to change it or just want to contribute or fix a particular bug. It gives you that ability. To that end, the community of Airflow users is extensive. I just checked the Airflow troubleshooting Slack channel, and it is over now 20,000 members. So again, if you're hitting a particular bug or anything like that, you definitely have the community to reach out to and learn from. Is another component, a core principle is its ability to be scalable. So again, Airflow allows you to increase the workflow. A lot of the components that we'll cover later are able to be made in a highly available fashion. So for example, the number of workers which conduct your Python processes, you can increase those and scale those out as you add more tasks, more dags, more processes to your Airflow environment. Again, what I mentioned before, connecting to some of those external databases or services, Airflow provides first-class support for you to do that in a secure fashion. And again, being built in Python, and also just its principle of being modular, a lot of the components are pluggable. So that gives you the ability to really integrate it into your current stack. If you have particular observability stacks, or for example, if you're working with some sort of central, your SRE teams working in some sort of centralized tool, being able to ship that out there as well. I see Bill, to confirm, are you saying essentially some sort of GUI based framework to create create these workflows?
Yes, exactly.
Yeah, no, that's definitely an interesting option. And I think, the way I've always envisioned that is some sort of framework that will allow you to create your code and then have that code be committed or pushed into your repo. Some sort of tool to augment rather than being, built necessarily into the framework, but definitely an interesting topic to discuss with the community, that type of support. So now we talked about some of the principles. We want to understand, well, what are we going to use Airflow for? And what we have here is a pipeline that is spanning a variety of different services in the data world, working with database technologies like, Oracle, Teradata, bringing that data to cloud storage such as S3, then utilizing some modern frameworks like Databricks to then process that data and then promote that data from S3 after it's done to Snowflake. What Airflow, again, being that extensible framework, allows you to do is to orchestrate these different processes. For example, if you're utilizing one of these, they may provide some scheduling functionality to schedule, let's say, your Databricks jobs or your Snowflake jobs. However, that extensibility allows you to interconnect all these different services across your entire stack. So if one line of business is utilizing, let's say, S3 and Databricks, but now your downstream consumers on your BI side are using Snowflake, your data engineering team can, have a end-to-end pipeline all within one solution and programmatically develop that. So going into all those different, integrations, how that manifests within Airflow is what's known as provider packages. And with Airflow 2.0, these were actually decoupled from the project, so they're available in their own distributions. And what that allows for is really independent development cycles. So that core Airflow for, if a particular bug, let's say in the, in our own provider package, the Astronomer provider package, right? That is can be patched and pushed on its own schedule versus as a part of the core project. So that gives a lot of flexibility because as you can see here, as of today, we counted 82 providers. And, I'm sure, with that vast wide community there, being decoupled allows, for example, if a bug needs to go in, et cetera, that can be patched quicker, and independently. So now I'd like to go into some of the core concepts of Airflow. And again, the dags, tasks, and operators are definitely at the forefront of, of Airflow. So what does DAG stand for? It stands for Directed Acyclic Graph. And again, it's a Python object that we'll see in the code example that you define, that defines your pipeline. So each of these nodes are your tasks, and those are your what is being conducted by your pipeline. And then also the edges between them are the dependencies, and that is the core of what it is defined as a DAG. The acyclic component, what that indicates there is essentially that it's, the way I like to think of it is that it moves in one direction. So if a task is downstream if, like, for example, here, task 2 is downstream of task 1, it could not be defined also as upstream. So you can see here in this example, task 4 cannot be both downstream and upstream of task 1. Another component to note here is that, being that they're written in Python, they're not declarative definitions. You can utilize conditional statements, for loops, different types of import strategies to create your DAGs. And how I've used that in practice, for example, is both creating templates that can be reused across different organizations, different teams in your organization, but also it allows for configuration-driven development. So if you think about creating a JSON or a YAML file, what you can do then is parameterize your DAGs in a for loop. So you can have a template, right? And then you can say, well, I want it to load this particular set of files and just have that be parameterized. So again, Python at the forefront and giving you, what you're familiar using Python to develop your data pipelines. I see David reached out a question here. Just to read it aloud. Can I use the same task several times as long as I'm not returning all the pipeline to a previous status? So David, the way I'm interpreting that is, can you, span for example, here, could you have this task, be 5 times written out and have it, for example, T2.1.2.3.4? Yeah, you can utilize, for example, a for loop to parameterize it, and they'll each have their own ID in the definition. Again, we'll dive into that when we see the code example. We have an example of that.
Or other case would be after T4, have T2 again.
Yeah, great question. What we can do in that case, a task will be defined once, but tasks are defined using operators, which we'll get into in, I believe, 2 slides, which allow you to have a template that you can then parameterize with a different ID. So again, first, before we go into operators, we'll talk about tasks. And again, those are the nodes in that graph. And those are the base unit of execution in Airflow. And in typical practice, they're atomic, actions. So it's where you're defining the work of your pipeline. And again, David, those are defined as operators, which are classes, which is what you would reuse and then parameterize with different parameters, for example. Most notably, a different ID. So for those tasks, then task instances are a run of that particular definition. So with Airflow, which again it offers scheduling capabilities. So what a task instance is you can think of it as a DAG plus a task plus a point in time, a particular run. And they have different state. So what we'll see in the UI is all this information of how your tasks were being orchestrated is available to you using this color key here. So some of the the most common or you may expect are success and failed. Running means that the task is currently ongoing. Queued indicates that the task is scheduled. However, there's a resource limit on or there's a resource constraint. There's not an available resource. And then another component there is up for retry, which is to note that Airflow allows you to, programmatically specify, hey, if this task fails, I would like it to retry n times with n interval in between. So an example where in my experience, we had task retry either 2 or 3, and that was because there was a network blip that would occur once in a while. And we didn't want to go sign in on Sunday to have to simply just rerun a task. So we let Airflow handle that, specified about 5 minutes in between, and then the task would resume because it was an intermittent transient error. So David, those operators are the classes that are used to define what a task does, and they are Python classes. So when you are defining your work, again, utilizing, defining your work in your DAG, you'll utilize these to determine what is actually going to be done. So going back to the community and all those provider packages, there is a variety of operators and sensors available for you to use out of the box and simply parameterize for your workflow. So here are three of some of the operators that I've used in the past. So for example, the SFTP sensor, that is an operator where you configure a SFTP endpoint and a file that you would like to look for, and then Airflow will essentially poke for the arrival of that file on that SFTP server. The bash operator and Python operators give you a lot of flexibility. They allow you to run, respectively, an arbitrary bash command, and then the Python operator allows you to run a Python function and parameterize that Python function. So if you've written a process in a functional manner, you, for example, do not need to, particularly, rewrite that as a class in Python in Airflow. You can take that Python callable and plug it into the Python operator and allow Airflow to schedule and run it. Something to note about operators that they all are derived from the base operator, which is defined in Airflow. And that has a variety of functionality like logging and other functionality built into it. But the primary work of an operator is defined in what's known as the execute method. And if you look at the base operator, that has an exception where that needs to be overwritten. So each of these operators will have a distinct execute, which will then define what work is going to be done. And I want to also highlight that you can build your own operators. Again, part of that extensibility model is that, in the past, I had to write a couple of custom operators that didn't exist in the open source yet, that I needed to conduct a particular type of function with, in my example, an SFTP server. And, I was able to use the base operator or even use some existing operators, inherit that, and develop the operator to meet my use case. So again, like I said, how I like to kind of coin it is if there's an SDK or a existing Python package or an API available, chances are you're going to be able to, cook up some Python to be able to utilize with Airflow and orchestrate that service. So again, we've looked at tasks, DAGs, tasks, and operators. And now just to put it all into context, we have a DAG definition defined with our dependencies. We have those tasks, and those tasks are defined using operators. So again, just to take all those concepts and put them all into context of how they relate, this represents that. So now we've talked about, the fundamentals of a pipeline and a DAG. I want to dive into some of the different types of settings that you can, and all the, the knobs that you can turn within Airflow to match your data pipeline's particular needs. So some of the, the base configurations that you'll see in your DAG are your start and end dates, which allow you to set bounds on when you want this DAG to first run and then to, conclude. You may see in a lot of examples that end date is not specified. DAGs will run, in perpetuity, data pipelines, but I've utilized, for example, end date where I want to run a backfill of data and I needed to replenish a year's worth of data. So I created a DAG to specifically do that and gave it an end date. Your schedule interval will define the frequency at which that DAG runs. And you can utilize a few different options there to specify how that interval. One way is to use cron. So if you're familiar working with cron jobs, you can utilize a cron tab there. So the example here will run every minute. If you want to use, some of the Python datetime functionality, you can use a time delta. And again, from the start date, this will run every 30 minutes. And Michael, yes, that is the next topic. That is exactly the next bullet to answer your question. So you can actually specify none for your schedule interval. So the object will exist, but the Airflow scheduling component will not trigger that DAG. And Airflow allows you to programmatically trigger DAGs both from the API, but also through the UI as well. So you can utilize the Airflow with version 2.0 has a full sustainable REST API. So you can specify a payload and trigger a DAG to run. So if you're using some sort of event-driven system, you can define your pipeline using Python, have that event-driven system, make a post, and then trigger the DAG to run. Now, if none of that happens to work for your particular use case, then with Airflow 2.2, which has some really great features that were just recently released in the last quarter, timetables was one of those features, and that allows you to develop, completely develop a plugin that defines the strategy of your scheduling, your scheduling strategy. So let's say your organization has a custom fiscal calendar, or you want a DAG to run on Monday, Wednesday, Tuesday, and Friday, just the days of the week. You can now, in Python, following the documentation, develop a plugin that'll allow you to do that. And you can have multiple timetables. So again, this is all specified at the DAG level. So you may have DAGs that need to run every 30 minutes. Great, you can utilize a time delta object right there to do that. Or you may have a particular one of the examples in the documentation that I really like is an astronomer needs to process data at sunrise, and that's going to change from day to day. So you're able to now build that with Airflow, again, using Python. And the last component that I wanted to touch on is catch-up. And it's pretty, the name is pretty clear. What it means is essentially, if I turn off the DAG, will it basically run everything that would have run? So for example, let's say we had a DAG that was set to run every hour and we paused it for 4 hours. If catch-up is true, then Airflow will ensure that those past runs will be scheduled and begin to trigger. Now, there are some cases, where catch-up may not need to be true. An example may be if you're refreshing a partition or a particular table with each run, and you're just looking to do that at some interval, then in that case, I would actually recommend to set catch-up to false, because you just want the DAG to run the latest run when you turn it on. So again, Airflow provides this framework to give you, all these options when defining your pipeline. Jitesh, yes, there is, with Airflow 2.2, there is asynchronous functionality, and I can definitely dive into some of that as well. They are known, if you're curious, you can research on the Airflow documentation. They're what's known as deferrable operators. And there's a asyncio event loop that runs as one of the components of Airflow.
Yeah, Rocco, I'll hold you to that because that's my question as well.
All right, yeah, definitely. If there's particular topics that the audience would like to dive into, we can go ad hoc. I'm happy to do that as well. So just to wrap up some of the scheduling configurations that are available. Again, this is now, I believe, could be the first look at what a DAG would look like in the Airflow UI for some folks. And we can see here these squares represent tasks. Each of these columns will represent a DAG run. And you can see here the status that we mentioned before: running, success, etc. So again, you can specify how many active runs you would like a DAG to be able to conduct at any time. And that's useful if you want to ensure that one DAG doesn't usurp all your resources. Another example is if you need a DAG to finish, let's say it's running every hour, and each run is dependent on the next hour. In a combination of utilizing depends on past, wait for downstream, and max active runs equals 1, you can create a framework where each run will have to happen sequentially. So again, depending on, again, what Airflow is looking to do is provide that framework to match your data pipeline's business and logic, the needs of that data pipeline, and then provide that framework to allow you to schedule it accordingly. And here is a different view of that DAG. And this is what's known as which we'll see in the UI, the graph view. And this is how I intuitively think about DAGs rather from a DAG run view, but this is the definition. So we again have our nodes, which are our tasks, their IDs, and then our dependencies defined between those tasks. So again, here, this is what we'll see is a task that was defined programmatically, as you can see from the index here. that's provided on each one of those task IDs. So again, similar to max active runs, we can also limit the amount of tasks across a particular DAG. We can also then utilize the evolution of that the way I like to describe it is task pools, and that's across your entire Airflow environment. So DAG runs, different DAGs, etc. At the fundamental task level, you can set a limit on how many slots can be utilized at any time. So in this case, for example, I have the pool that I created, bash print date, and it has 2 available slots. So in this case, you can see 2 are running, and if the other DAG runs, no other tasks with that pool would be able to run. It would lock that. To put that in perspective, how I've utilized pools in my previous work is to limit to a pool of 1. And what that ensures is that across my entire environment, whatever processes are running, that those tasks with that pool could not force any type of race condition. I was working in a system where I had an hourly process that was updating data, and then a daily process that would refresh a certain column. It was a columnar database. And I needed to ensure that those 2 write operations never happened concurrently. It would cause a corruption on the file. So again, utilizing Airflow, I simply specified a pool of 1, set that configuration in my task, and I was ensured that particular operation would not occur. I see a couple of questions coming through the chat here. I'm going to pause for a moment to go through them. I see, is there a time duration for a task to finish? Can there be long running tasks that run for days? Absolutely. And to note on that, there's a timeout parameter that you can specify so that, for example, if you want to ensure that, let's say you have a task that you expect to run at most for an hour, and you may want to put an execution timeout on that for 3 hours because it may be a hanging connection or something, or some sort of error, right? And you want to make sure that that slot ends. So you're able to specify that. But yes, you can definitely have tasks that run, and you're able to configure how long you'd like to allow them to run. And Matthew, the difference between a operator and a task, what I'll do is I'll go back quickly to that there. So an operator is the Python class, and the task is the actual object in Airflow that is created from that operator.
Got it. Thank you.
No worries at all. And then David, I see limit the concurrent task in just the same DAG. Can it be a global limit? You have both options.
Is the pool, right?
Yes, you have the pools, and that allows you to think about tasks fundamentally. I think we've had some discussions about this, some of my colleagues, and DAGs tend to be kind of the star, but really the task is the star of Airflow. And that allows you to, obfuscate DAGs and think about tasks. So exactly, David, if you have 2 DAGs that are running processes that need to ensure some sort of lock between each other, a pool will allow you to do that right within Airflow. Oh, I see. Got it. The pool does that. Missed that response. And that, can DAGs be made of DAGs? So Matthew, would you be able to share some context around that question? Is there a particular use case, or are you just
no? Just, is that a valid way of looking at it? Like,
yeah, I would think of DAGs being made of tasks.
Let me tell you this. Is there an operator to run a DAG?
You can, yes, there is a trigger DAG operator, which you can use to trigger a DAG run.
Then
Okay.
I think Matthew's question is yes, you can.
so
Sorry, Matthew.
You could compose a DAG of several triggers of other DAGs.
Yes, you could do that.
Okay.
And definitely, I think I didn't cover it in this particular discussion, but what's known, we have some webinars at Astronomer and some documentation that we produced around what's known as cross DAG dependencies. So basically, if I have one DAG that loads a set of files, right, can I have n downstream DAGs that rely on that DAG finishing without defining them in the same definition? So I have DAG A, which loads the data, and then I have downstream consumers from different teams that want to have their own DAG because they're maintained by different teams, but then want to begin once that dependency finishes.
And if I may,
Yeah, please. Yeah.
In the case in which a DAG is triggering DAGs, is it the responsibility of the developer to ensure that nothing is cyclical? Or
So
like
Airflow will, right. So are you basically saying like, yeah, so great question. And the way to think about that is you'd be triggering DAG runs. So going back to this, so you'd be creating a new DAG run.
okay,
So the DAG run itself would not be cyclical. This would represent a single DAG run. So you can have multiple DAG runs of the same DAG.
okay. I mean, like, you know, like for some reason, a child DAG triggers the parent DAG.
Right. So yeah, could you have basically a ping pong go back and forth of DAGs triggering each other? You know, I don't see why that wouldn't be the case. You definitely could have, you know, because essentially what the trigger DAG operator is doing is utilizing, I believe it's utilizing the underlying functionality, but we could think of it as essentially just triggering the DAG from the API.
Okay.
Any other questions, or Matthew, or any other ideas?
Yeah, I had a question. If we could go back to the slide where you had the schedules, how you could schedule the cron tab. Does Airflow just use the cron expression to deduce the schedule you want, or does it actually use a cron process to like schedule it on the system that is hosting this Airflow process? I ask because of Windows. I don't think Windows has cron natively.
I believe it's utilized. It's basically, is cron a part of the Airflow underlying Airflow?
Yeah,
I would need to dig into that. Yeah, I believe when I last took a look at some of this code, I believe it's utilizing the expression, and then rather than using like cron fundamentally.
I think that's right. I think it's using something like Croniter, which is a Python library to parse cron tab expressions to then schedule inside the scheduler, which is not dependent on the system having cron.
And I would think my intuition says that would be true because of the different options you have, right? So it's more just an input that would be parsed. So similarly, right, I could write a time delta. I could write 30 minutes using cron or the time delta.
All right, thank you.
Yeah, no worries. Thank you for your question. So we've talked about scheduling. We've talked about, you know, really developing our dependency tree. Now, these tasks are conducting work. We saw the option you could be running a Python function locally, but you know, in many cases, you may be connecting to external services such as a cloud database, cloud storage, and again, your Airflow DAGs are defined programmatically. And I'm sure, you know, somebody will yell at somebody if you have a secret key somewhere in your code. So Airflow provides, a first-class way to address that in what's known as connections. And if you see the example on the right here, this is from the UI. It's a form that allows you to input your information into one of the components we'll cover later is the Airflow Metastore, which is a database, and out of your code. And then you're able to reference those credentials in your task, referencing that particular ID. So you can see here, this would be an argument in one of our tasks in one of our operators that references that particular connection ID. And again, the purpose of this is to ensure that your credentials are out of your code, not only from the security perspective, but also from the perspective of not needing to promote a code change. If your key expires, right, you can go and update that independent of your Airflow DAG definition. And depending on what service you're connecting to, there are a variety of connection types available. And what we'll see in the UI when we go to the demonstration is, depending on what you select, different parameters will appear. And that's going to correspond to the class, the operator that you're using. So if you're, again, whatever service you're looking to integrate with or interact with that, may require different parameters, that form's going to give you those options there. So typically what you'll see in the provider packages and the sets of operators, those that we mentioned before, there's typically a connection type that's shipped with that as well. And there's a couple, so using the base Airflow functionality in the Metastore in that database, those secret pieces of information are encrypted using Fernet. And going back to that extensible and modular, principles of Airflow, you're also able to integrate with a secrets backend. So if you're utilizing, for example, Vault to store your secrets, you can store those as a URI in Vault and then have Airflow read from Vault. So again, giving you multiple options to ensure that your connections stay out of your code and in the tool that's approved by your InfoSec team. On that same vein, there's the concept of Airflow variables, and this is again just a way to provide a key value store within Airflow. You can think of them as an analog to environment variables. You can still use environment variables within Airflow using like the Environ module. But this provides a way for you to, store particular key value pairs. Again, if you have something that's changing frequently or something independent to your DAGs and development lifecycle, you can have that be referenced there in the Metastore, or again, in a secrets backend, and then programmatically reference that value within your task definition. Something that we'll note in some of the example is Airflow also has Jinja, which is a templating engine. As a part of Airflow. So you can also use Jinja. So if you have a string and you want to render a template using that variable. So another component that I wanted to dive into was cross-task communication. So again, going back to this example, each of these are their own independent processes. So each of these tasks. So when a task, is complete or fails, etc., anything that was in memory is lost. And you may have information that you need to pass along the life of your DAG that's necessary. An example for from my experience was we had an SFTP sensor looked for a file. If it found the file, it would pass that information to the load task in the tree, and then finally in the promote task, we would pass then the table that was loaded so that it could be appended to the production table, following like an ELT model, where we would load the data to a staging environment, run different types of data quality checks, and then append that once it was ready. So what XCOM allows you to do is have a way to persist information across tasks. So in the case that I described, you find a file, you persist that file name to XCOM. That will push that to a table in the backend database, the Metastore. And then it'll be referenceable again in a key value format in your code. So these are little snippets that we'll see examples of in the code example that allow you to reference a particular task, a particular key, and pull that value down. So without further ado, we will dive into the code so we can see some of these principles in a definition of a DAG. And also we'll go into the UI to see this DAG rendered. So I should have downloaded PyCharm, knowing the conference I was coming to. This is VS Code. I could have used Sublime as well. But this is a DAG. This is my DAG file. So this is a tutorial DAG we built here on the team. And as you can see here, we've imported some of those operators, again, coming from some of the base Airflow, similar with those provider packages and different, if operators come available and other types of, you have your own customized, packages your teams may develop, you can, build those in and import them. So going here, again, here's that DAG object, our definition. And here's some of the parameters that we went through, previously. So you can see here, we have our ID, which is a global unique ID that for that DAG. Our start date, which is today. Here in our schedule interval, we used a time delta. And here we're specifying every 60 minutes. So that'll run based on the start date, that'll run at the top of the hour every hour. catch up true in this case, so that when I turn on the DAG, it would run for the, for the entire day, which I did just before I joined the call. And then again, some of these concurrency parameters that we're talking about before. Utilizing a context manager, we have our task defined within our DAG definition. So again, to bring, now to take those examples and put them, to paper, these are the classes, these are the operators. So your Python operator, your bash operator, and then we parameterize these, right? So we're able to reuse the bash operator and then give it a new task ID, uniquely defining it within the DAG. And then different, for example, the bash command we'd like to run. As I mentioned before, we can specify the pool at the task level. Again, this is something defined globally across DAGs and at the task level. So in this case, we have that bash print date pool, which has a limit of 2. And then what we'll do now is look at an example where we're utilizing a for loop to generate our definition. As I mentioned before, that hello world var task ID, and then we're utilizing the task number here. And we're able to generate in this case, 5 unique operators that we can use in our DAG. So if you need to distribute load or you want to, programmatically define your DAGs, you're able to do that. Well, what I'll now go into is defining the relationships, the dependencies between those DAGs. And you can use, I believe it is, I haven't used them in a while, but set upstream around the task. So you can do something like t1.setUpstream and then specify the task.
Aye.
Oops, was that? Sorry. Just wanted to make sure if someone had a question. But the other, what I've seen most commonly is to utilize this bit shift notation. So you can specify, for example, D0 is upstream of TN. And the TN would be the reference to the object there. And you can also use that notation as well if you'd like to define your DAG in that way. And again, you can define, for example, in this case, we're defining both D0 downstream of TN and D1. And D1 again and TN, those are just the objects, the tasks themselves, references to the tasks. And then from here, we can see we're utilizing a list so that we can basically, another way to write this would be right. So we're able to compress that utilizing a list, and there's a variety of different utilities to help you, as you have different types of, complex pipelines that you may need to write. The community has contributed essentially a set of helper functions to help with that. So again, utilizing some base Python there to help define your dependencies.
And it doesn't matter what order you specify them in the code, right? It'll generate.
Yeah, this is
based on like what's related to what and what comes after what.
Yeah, absolutely. Like I could the way I've defined this, what I've seen in practice is you typically do define them in some sort of order, because when you're reading the code, right, looking at the definition, you're thinking about it that way. But to answer your question, absolutely, I could define these in any type of arbitrary order. And this is what is parsed as part of the DAG definition. This is what is used.
It's only one relation by for line, or can I do the D0, TN, T3 in the same line?
Absolutely. So I could do this instead.
Perfect. And what happens if I mess up and and do a loop?
Yeah, if you'll have an import error. So the DAG, it'll throw and we can actually we can try that here actually. So I'll add that there. So now we've seen that we've created that issue, that cyclic relationship. And what I'll do now is I'll go to the Airflow UI. And quickly what I'll do is once the DAG is rendered, you can see I have an import error. Cycle detected in DAG, faulty task. So you'll be able to catch that as part of your CI/CD process. You can run that import as part of your CI/CD process, and that way you can ensure that nothing gets pushed to production, right? That would cause that type of import error. I'll quickly switch that back.
Excellent. So it's a compile time error, right? Not a RAM error.
Exactly. Yeah, the DAG object. So the scheduler is reading that DAG, these DAG files and parsing them. So it wouldn't happen when your DAG's ready to run. The DAG object would not even be able to be created. So we've corrected that back now, and now we have our DAG. So this is the Airflow UI. Definitely gives you introspective into your data pipelines. And in this case here, we have one DAG. If you had multiple DAGs, you could have, I think you can specify how many DAGs you may have in a page, but then, you'd have multiple pages. And from the DAG level view, you'll have, for example, some summary statistics of, the recent task runs. You'll understand when it last run based on UTC. So in this case, the last run happened about 5 minutes ago with the execution, the data interval start of, midnight UTC. And then again, some more information for you to understand at a task level, those states that we saw before, some summary level information. So if your SRE teams are looking, they can see really quickly if they're monitoring the UI, for example, that, okay, there's some failed tasks in here, I should investigate. So let's dive into, David, exactly what we're about to jump into. If I click on tutorial DAG, we now have a variety of different UI options that we're going to dive into around this DAG. So this is what's known as the tree view. And what this allows you to view is your DAG across multiple DAG runs, those task instances. So again, here we have our in this case here, our Python Hello World var2 task ID across multiple runs. So we can see here, if you look at the run, we can see that it is 2 a.m. UTC on January 11th, 3 a.m. UTC, right? Those are the individual task instances. Now, to look at the DAG at what I think of intuitively as the DAG definition, you utilize what's called the graph view, so that you can see the DAG and its dependencies, written out from left to right. So again, here we have our start task, those programmatically defined tasks directly upstream, and then downstream some of those bash tasks as well.
And does everything at the same level run in parallel?
So yeah, that definitely, you have using those settings and also how you define your DAG will determine how things will run. So if you, for example, I'm going to trigger the DAG here and I'll go to graph view and I'll go to, as you can see here, these three are running. They have been, and they were running in parallel. As you can see, as I mentioned before, the print date is limited to 2 by the task pool. But if you need, tasks to run in parallel, for example, you can definitely configure that as you saw here. But if you need to limit that, you have all those knobs to tune that to, again, the business needs of the data pipeline. Is there a particular case you're thinking of, Matthew, or just?
I'm still trying to come to grips with Airflow. Yeah. No particular case.
Sure. I have a related question. If you have multiple DAGs inside the system that are not necessarily directly dependent on one another, but you've got one data source maybe that they're all drawing from, is it possible to limit the number of connections that can be made to that one data source? So that, say, all the DAGs start running, but like so many of them run in parallel, but maybe they get so far down and you don't want to you don't want to do a denial of service against your source.
Right. No, and you, exactly. And you would want Airflow to essentially have that mindfulness to say, well, I'm about to run 15 tasks that connect to this single source. Let's queue these up. Let's not let the source even know that we're about to run those. We'll queue those up and run those. And that goes back to what we were discussing before, which is pools. So this allows you to specify a number of slots that are available. And you specify this Calvin, at the task definition level. So across your DAGs, again, when you're defining it, you can say, okay, these are all hitting that same bucket, right? And you want to just limit the number of concurrent connections. You can specify, bucket X, and then any task when you're defining your DAG that would hit bucket X, you can give it that pool. And then your admins, for example, can specify, okay, this is built to, maintain this many connections, or we want to, whatever, we just want to ensure, another team's using it, whatever it may be, and they can specify it here. And again, that can change without your pipeline updating. So
Okay,
this is handled, yeah.
It's critical that then the developers of your DAGs have like a library of common tasks, like connect to this data source that they all use across their DAGs so that you can leverage this pool.
Yeah, I would say that definitely you want a perspective of what tasks are using that pool.
Mm-hmm.
But at the same rate, right, the slots are going to determine. So if, let's say I commit 100 new tasks that use that pool, if the slots are limited to 5, those 100 tasks, even if they're set to run concurrently, Airflow is only going to allow 5 of them across all DAGs to run.
That's
so your
awesome.
admins can really just, if somebody, they will eventually run, right? But as long as there's no rate limit, right, it's
Right.
in accordance with that rate limit. Whoever, and setting the pools can be set to a different role within Airflow, which again, don't know if we'll have time to jump into that today, but there's role-based access within Airflow.
Right. It means you don't have to be carefully scheduling manually these things. You can let the queue
Absolutely
handle to kind of absorb all that.
Yeah, they'll go into that state of queued and they'll wait for that slot to be relieved.
On the same topic, correct me if I'm wrong, but these tasks that you you configure these pools for, right? Does that mean that a task, there can be multiple instances of the same tasks, like as a system process running? Is that correct?
Do you mind repeating that one more time? I'm sorry.
Yeah, I was asking so the task called bash print date.
Right.
If you set it to have a pool slot of 2, does that mean that there is 2 system processes that have the logic for the bash print date happening? So essentially there's 2 Linux process that are running bash print date. Is that how it tasks relate when they are running?
Yeah, great question. And it's when we dive into, I know Calvin, it was 8:30, correct? 8:30 Eastern is when. So we definitely have,
as long as folks want to kind of hang out.
Sure. I just want to make sure.
But obviously not too long, because we want to get the door prize out for folks who don't want to hang out.
Absolutely. So to answer your question, what it has to, essentially this is at an Airflow level, right? Airflow has a couple of components that when we will go into next, which are some of the core components, and that has to do with the executor. So from Airflow's perspective, you're allocating 2 slots for it to then, the scheduling component of Airflow, to communicate to the execution component. 2 slots are available. You can have these resources be requested.
Okay.
Now, if
piggybacking.
Yeah, sorry.
Oh, sorry. I was gonna just piggyback off what Calvin was talking about, where you don't want to denial service your source. What's better to do? Would you create a task that maybe it's pulling different subsets of rows, like maybe it is doing paginated query from a data source, like a database, and you do a for loop to create multiple tasks for each page in that paginated approach? Or would you write all the logic for the pagination inside one task? Which one would be better?
Yeah, great question. And the answer is in Airflow 2. In current Airflow, tasks are defined at what's known as essentially parsing time. So for example, this for loop would define when the DAG object is created by the scheduler. That definition is then created this parameter, for example, would not be changed at runtime. That is coming in a future version. It's what's known as dynamic tasks, dynamic task mapping, which allows you to say what you just specified in exact case. I have 100 files on my source. I want to create an individual task for each of those files. So first class support for that is coming in a near future version of Airflow. I believe it was actually merged into the main branch recently, part of the commit.
Okay, but if you don't have that newer version for some reason, what would you do to still achieve the same thing, where you want to query a data source, but you want to do it in a paginated fashion,
right?
Because like you want to do like something like a map reduce sort of method,
right? So in that case, what you could do is you could have 5 operators and then distribute the load to each of them, right? Where you can have a task, say, upstream. So just using this as an example you could have one task that could read the source and say, okay, there's 100 records, and then also distribute essentially to XCOM, right? The 100 records to for each of these to pull down a portion of those.
Oh, okay. And so like you could create 5 versions of a task, and those work as like little workers in a worker pool, processing the data.
Yeah, so like I'll show you an example of like we saw in XCOM. What you could do essentially is have like return value _1 through n, and then have the rows or the records or the items that you'd like to reference. And then the downstream tasks would know to pull the appropriate key so that it knows, okay, I'm doing rows 20 through 40. I'm doing rows 0 through 19.
Oh, okay, that's cool.
There are also operators for Hadoop and Spark and other things, right?
Yeah, and this is definitely a good topic, because with Airflow, you can run things locally within the Airflow environment using a process, right? You can start a Python script locally within Airflow. However, to David's point, we can communicate to an external data technology, hey, run this job, and then it would run, for example, if it utilizes MapReduce and its query strategy, right? And then Airflow would be orchestrating, essentially, when it receives that terminal status, it would succeed and then kick off the next task. Yeah, Drew, definitely we can share. I think we'll be able to share, if not all the documentation and examples, we'll definitely be able to send you that tutorial DAG to utilize. And also what we'll touch on at the end is the Astronomer registry. And that has actually, I'll jump into it quickly now. And what that is that we've curated all the different provider packages. So if you have a particular, data, so for example, if you're working with, let's pick Databricks, for example, you can look at the different available operators to define your tasks, depending on the module as well. So if we go to Snowflake, I know that there are some example DAGs as well. So if we click on this, we can see an example DAG, and then you can, Astronomer ecosystem and field team have developed these so that you can take these examples and start, running them in your Airflow environment. Oh, thank you, Adam. So yeah, going through the UI, there's some other information that is available to you. So for example, here, we can look at a Gantt chart to understand really the task run times across your DAG runs. Basically, we've utilized this in the past, for example, where we saw that one particular task was holding up a DAG run, and we were able to quickly, visualize that and say, okay, this is the task that's actually taking up a lot of time, which is holding up a particular resource. We dug into that and saw it was doing some inefficient use of resources. It was actually looping in that case when it shouldn't have. So we're able to, utilize this to really visualize these processes, understand the metadata around them, and potentially optimize as well. So you have that observability through the UI. And of course, this information can be shipped to a particular observability tool that you're using at your organization as part of that modular framework. Any other questions or anything in particular that we didn't cover in the UI that folks would like to see? Happy to do that before going into some of the underlying components of Airflow.
You're saying UI specific questions?
But UI specific, or happy to answer any other questions as well.
On Jinja templating, is that only usable in certain contexts or scenarios?
Yeah, great question.
Yeah,
So
'cause I've had trouble with that before.
yeah, definitely. So if we go to the operator's definition, the actual definition, you'll see a field known as template fields. And so basically within the operator's definition, the fields that can be specified as templatable are there. So what I'll do is I'll pull up the Python operator, for example.
I remember reading this, and yeah. Oh, sorry. I'm reliving a moment here.
No worries at all. I'm going to pull up the, I'm actually going to go back to the registry here, and then I'll go to the Python operator. Or right here, and again, the registry allows you to have the open source documentation in a searchable format with examples and other relative piece of information, how to install this particular and utilize this operator in your own Airflow environment. So if we go to view on GitHub, that'll actually take you to the main branch of the source code. So if we look at template fields here specified, so you can see here in the Python operator, Matthew, these are the fields that are available that will actually be treated by the rendering engine at runtime.
Okay. So the Jinja templating is supported for specific fields in operators only.
Correct. Yeah. So specific fields within operators can utilize Jinja templating.
Okay.
And then I recently made a commit to add a template field because I had a particular use case that made that utilizing template fields, again, because we wanted to run the information at task runtime rather than at DAG parse time. I was able to simply just add that argument there, and it was approved and included in the project.
Yeah, I've heard something like it's not best practice to do a variable.get. You should prefer to use the Jinja templating. Is that correct?
Yeah, that's a great point, and it's why I made a point to use Jinja templating here. And the reason for that is, again, that information is stored in the database in the backend. So
What is
the variable information? So if you're running each time the DAG's being, run and parsed by the scheduler, it'll be making a connection to pull that in. However, you really only want that variable at task runtime. So what Jinja allows you to do is to utilize this notation to render that at task runtime so that you're only making a connection when you truly need it.
how bad is it to not do that and then opt for the variable.get blah blah blah? Like, is that like a massive performance hit, or it could be problematic in certain scenarios?
Yeah, definitely. It'll depend on essentially a variety of factors. One is basically, how often your DAG is being parsed, which can be, these are definitely some more in-depth. I'm happy to, discuss these too. But it's unnecessary connections to your database. So if you're running a large RDS instance, you may not notice it, right? But you're making those connections and holding those connections when it's really not even utilizing them until you actually run.
I had a question.
Oh, yes.
Do you mind talking a little bit about how you host Airflow? So in terms of like running it on a Windows server versus a cloud, how does that all work? What's the development experience like? or the DevOps experience like?
Yeah, you're perfect segue into where we're about to go next. So what I'll first do is talk about the components of Airflow, and then the final topic I want to cover is how you can start running Airflow to start running Airflow from either following this call or tomorrow or in the future.
So if you're getting ready to dive into the infrastructure pieces, I have a question before that then, which is more about the like operators and async.
Yes.
If that makes sense now.
Yeah.
So it seemed like Airflow prior to 2.2, it was still doing a lot of polling. So if you had an operator, it would like poll against the source. Does the new async allow it to establish some kind of long running connection, like a WebSocket or some kind of using whatever native asynchronous services may be available on whatever data source or service you're connecting to?
Yeah, exactly. And you hit the use case spot on, right? So going back to that example, you trigger a Spark job on a cluster, right? And it's Airflow is just polling for that status. So for example, let's say you have Livy, right, on the Spark cluster, utilizing that API. And if you look at the current Livy operator, what it'll do is submit that job, return that job ID, and then just as you noted, Calvin, poll for status. Now, what that will do in your Airflow environment, I'll jump back to the UI, is it will hold that worker slot. So this essentially we could think about the that worker slot, that particular resource during its run will be set to running. And it's really just waiting for status. What deferrable operators, which introduce async functionality into Airflow, look to do is to relieve your worker. So when I mentioned running, so it'll be running for, let's say, 4 hours, right? And now that worker resource is effectively idle. What deferrable operators allow you to do is to put the task into a state of deferred, write an async piece of Python code, what's known as a trigger, and then that trigger will be submitted to one of the new core components. So you can think of a scheduler. It'll be called a triggerer, clever with the naming, and that'll be run there. Now that'll have to be written, for example, using asyncio. It'll have to be awaitable, so you don't have any blocking calls or anything like that. But if you're thinking about a REST API, I believe the package is called like AIO HTTP is a Python module that's available for async in that context. So if you're, interfacing with that type of REST API, you can, really look to build that operator to conduct that. And the advantages of that, as you mentioned, is your worker resource is no longer just sitting idle. It's that polling process is being put into a resource that is optimized for that type of workload. And you get a lot more concurrency in that way from that single resource. Another advantage is actually, I just recently wrote a guide that I'll share with the team on deferrable operators for Astronomer. So we can share that as part of the resources as well. Let me see if I can pull it up quickly.
Do you know support in the various community provided connectors? Is there a lot of async support yet, or is that still coming?
That's still coming, and Astronomer, we have developed as part of our runtime image some asynchronous operators as well.
Okay.
But it is relatively new. I'd say, I believe it really was developed, released in late October, early November of last year. And it's available with Airflow 2.2.
Yep.
So what I'll do here is, I believe I have the docs saved. I'll try and find it really quickly. I think it'll be great because it has some visuals that are really helpful when discussing this. Just one moment. There it is. Okay, we are back. So yeah, so I'll share this actually in the chat here, so folks can reference it later. But this is a guide that goes through basically a lot of what I was describing in more detail. And that what I was describing there, right, is what Calvin, you were mentioning, right? You submit that job to a Spark cluster, you poll for status, and you receive that terminal status. That whole time the worker slot is allocated, that polling part can now be offloaded to that trigger process and be an asynchronous polling process.
Now, is it possible instead of even doing the triggering process to have it register some kind of a callback like webhook so that you get a notification actively?
Now, are you,
Like if I submitted a job, maybe not Spark because maybe it doesn't support this, but if I had a service that supported a callback, like a webhook they would fire on completion,
right?
it could actually call back to my Astronomer or my Airflow instance to basically tell me that that thing's done.
Yeah, that's an interesting. I see what you're saying. Like I'm thinking
Sounds
of
like I'm reaching now. I got new feature creep going on here.
no. I mean, one way I'm thinking of that, right, is you would have a submit task in one DAG, and then you'd have a downstream DAG that the webhook would know to trigger.
Would hit, yeah.
So it would be a different, like I'm just thinking of the, any potential edge cases that I've run into at certain other types of situations, but you could develop that type of framework in that way with multiple DAGs, just thinking out loud here.
Yeah, you could think about it like with like SNS on Amazon. If you had a queue and it hit whatever your job was done, it hit that SNS queue, it would fire a webhook back to whatever URL you have configured as the post for it.
Right. Yeah. What I'm thinking about is is ways you could achieve that versus, there is, for based on my understanding, there's no like feature that would
not built in, yeah.
Right. But there are, we could definitely, I'd be happy to chat about that, kind of jam on those ideas. There's probably some ways where you could achieve that with, achieve that within Airflow, utilizing like the API and just some architectural decisions.
Okay. No, I appreciate it. Thank you so much.
Yeah, my pleasure. Yeah. So this is, some of these components like the worker and the trigger, we will cover in the next bit of the slides, but yeah, please, this is also one of many of our guides. So as you are learning about Airflow or interested in a particular Airflow topic, just, remove the deferrable operators from the URL, and you'll be able to search for, guides on different types of topics. Timetables, like we were mentioning before. In this case, we have a whole guide on integrating Airflow and DBT for any folks that are looking to utilize that. SageMaker for machine learning use cases. I know we mentioned this earlier too, cross DAG dependencies. So we have a guide written on that as well, and the team's actively adding to this and updating this information as Airflow is evolving. Great. What I'll do now is I'll jump back to the presentation. And then, yeah, so we mentioned some of these terms. Now let's define them, right? So if you think about the Airflow environment, what you have is a web server, which is serving the UI that we were just interfacing, previously interfacing with, as well as the REST API. The scheduler, which is really that brain of Airflow, which is determining when things need to run, that they're triggered, and essentially, based on the dependency and all the configuration settings you set, when things should run and if they should run. The Metastore, which is a database, and typically Postgres is what we would recommend to folks looking to get started with Airflow. There's some performance benefits that the team has recently pushed as well around Postgres that are definitely, in my opinion, worth looking into a Postgres option around creating your DAG runs and executing, setting those DAG runs up to run. Your executor, which goes back to what we were talking about before, is basically defining how your tasks are executed. So two common options for that are to utilize the Celery executor or the Kubernetes executor if you're running Airflow on a Kubernetes environment. And then the other is what's known as the local executor, which will run within your scheduler. And then you have a worker, which again is actually conducting the work. So again, thinking about if you're working with Celery, you'll have a set of workers, and the tasks will be distributed to a queue, and those workers will pick up tasks off the queue. If you're working in Kubernetes and utilizing the Kubernetes executor, each individual task will be given its own pod, which is the fundamental compute unit in Kubernetes, and will run in its own isolated process. Finally, the triggerer, which is what we were just talking about. It's a new daemon running an asyncio event loop, and that's what's used by the deferrable task for those polling type scenarios. Jitesh, and when you say scaling, do we mean vertically scaling in terms of you have tasks that need more memory, or scaling in terms of horizontal scaling for concurrency?
I'm talking about horizontal scaling. If you have a
Yeah.
larger number of tasks, right, and I've had to
Yeah.
distribute it, probably I guess local executor will not work, right, in the scaling.
Yeah,
scaling way.
you'd want to go, I would recommend in that type of scenario, Celery. And if you're orchestrating services, like hitting APIs, right, a combination of Celery and 8 deferrable operators, right, will give you a lot of parallelism and a lot of concurrency across your environment, a lot of bang for your buck. With Kubernetes, right, there's the overhead of, and if, if folks aren't familiar with Kubernetes, it's a container management software. And there's the overhead of spinning up those pods. Like, you may not get as much bang for your buck, right, where you could, with a single Celery worker, depending on the resources, run multiple tasks. And you also have with Celery, the resources are generally static unless you configure some type of auto scaling. So the latency is that as soon as the task is and the resource is available, the task will begin to run.
Okay, cool. Thank you.
Yeah, my pleasure. So yeah, we have all these services. Let's look into a case, right, of how they all relate. So what we have here is a example and kind of, a DAG, if you will, kind of meta here, defining dependencies, although it wouldn't be a DAG. Any takers why?
Not acyclical.
It has loops.
Yes, exactly. Exactly. I was waiting all night to do that pun. So excited we got there. So the scheduler is going to, again, read your DAG definition files from the DB, from the files. It'll schedule a DAG to run. So what it will do is communicate to the executor, okay, these tasks need to be, given some resources, depending on the executor, which again is a pluggable component, depending if, like I said, Celery, Kubernetes, local, that'll determine essentially, how the tasks will run. Then your worker resources will be allocated in the case of Celery, they'll pick up tasks off the queue. Kubernetes, they will, it'll communicate to the underlying infrastructure, hey, I need some pods to run these tasks. Now, again, in your worker resources, they may offload that work to the triggerer, and then that will come back potentially to the worker. And, during this time, right, we're all monitoring this, viewing the progress through the web server, watching water boil, refreshing our DAG to see the progress for a 4-hour job, even though we probably should go and, finish some of that other, that work we needed to do. So that was a simple example. There's definitely a lot, more relationships of how these things interact, and definitely a lot more that we could dive into for each of these components, but wanted to give a high level overview of how, a task goes from being scheduled to, success. So going back, I believe Nick asked this, how to get started with running Airflow. There's a few options I put in here. One is running Airflow with Docker. So there's an Airflow Docker image that is available. Some of the benefits, right, of running Airflow with Docker, you can basically have that containerized. If you have Docker desktop, right, you can spin that up and have all your dependencies packaged up in that way. If you go to the Airflow Docker Hub, you have each version of Airflow and a combination of what images are available. So you have Airflow version and then the supported Python versions for that particular Airflow version. So that's a lot of that's noted in the documentation, what's available depending on what version of Python you'd like to use, and if that's supported for a particular version of Airflow. And the list of Docker images are available on Docker Hub. Another way is a tool that Astronomer has created, an open source CLI tool known as the Astro CLI. And what that will enable you to do is to For example, if you're on a Mac, you can do a homebrew, install the CLI, and that will take care of, you know, some of the components. If you're familiar with Docker, like writing a Docker compose file, starting all the individual containers, you can run a few quick commands after install to get an Airflow environment running. And that's actually what I was using to run the Airflow that we were working with. So that was all running on my local machine, utilizing the Astronomer CLI. So we have our own at Astronomer open source Docker image of Airflow. And here's the Quay repository. So you can, again, pull the appropriate image for you, but we include in our image build process, packaging up our dags. Again, if you're looking just to get a quick start with Airflow and you have Docker desktop, and we actually have Podman support as well now, recently released, and you just want to get quickly started, you can, you know, utilize that with a few quick commands after install. And what will be produced for you there is a scheduler, a web server container, and a PostgreSQL Metastore container as well, running local executor in that sense, in this case. So if anyone has any questions about that, definitely, or just wants to get started, again, if you have Docker desktop, a few quick commands and you can have a local Airflow environment ready to go. And you could pull some of those dags off the Astronomer registry and, you know, start testing out some particular workflows. And now the last thing I wanted to mention is running Airflow on Kubernetes, which I think is one of the ways, if you are thinking about, you know, utilizing Airflow in a production setting, is definitely a option to consider. It is how Astronomer runs Airflow and all of our available offerings. There's an open source Airflow Helm chart. Oh, there's a typo, Helm chat, but Helm chart. And what Helm is a package manager for Kubernetes applications. And, you know, Airflow on Kubernetes provides each of those resources that we defined here in their own individual, what's known, again, pods. So they're all isolated in their own compute units. Kubernetes is providing the management of those containers. Like if one of those pods was to go down, Kubernetes will attempt to reschedule it as part of its core principles. And there's also some neat features that you're able to utilize with a Kubernetes installation of Airflow. What I was referring to before, the Kubernetes executor, and then the Kubernetes pod operator, which at a task level allows you to define a pod and an image to run in a particular task. So if you have some containerized processes that you've developed, right, that you've built, and, you know, for a particular type of workload, you can, you know, purely orchestrate that with Airflow in their own individual pods, utilizing that operator. And thank you for everyone for, you know, I know everybody was really here for the prizes, but I appreciate everyone here, you know, everyone's time. And it was a pleasure to speak to all of you. And if you have any questions, do not hesitate to reach out. I know, you know, Will and I believe Will is here as well. You know, we can definitely reach out to us. I'll provide our information as well. If you have any questions or, you know, anything related to Airflow, happy to answer those.
This has been awesome. I mean, if folks have some more questions, we can probably take a couple minutes for questions. Otherwise, I'll jump into some door prize drawings. Rocco, thank you so much for being with us. That was a really good introduction. I think a lot of people, I got something out of it, even though I'm an Airflow user.
Yeah, my pleasure. Yeah, please. Questions are great. I love
any more
answering
questions? Feel free to turn on your mic or turn on your camera and ask away.
Yeah,
actually, Rocco, your camera is off right now, so I can't see.
Yeah, during presentations, I like to turn it off because sometimes I catch myself and it just find it a distraction.
I could totally get that.
Yeah, great presentation, Rocco. Was really, really informative. When you were showing how to set up Airflow, it seems like there's a lot that goes into it. It's more than just the Python package. Because in my mind, I thought, okay, boot up my laptop and just pip install Airflow, I'm ready to go. But it seems like there's more I need to do, right? Is that correct?
So it's a great question. So there is some quick start documentation if you want to run Airflow locally, right? Just utilizing your laptop environment. So I can also pull some of that quick start guide. I just, with time, I want to talk about the Docker and Kubernetes options, because they provide a bit more, you're packaging everything up, right? You're able to share that image, right? For example, if you have those provider packages, you can build that image and then ship that to, hey, Calvin, I'm hitting this bug, right? That way he doesn't have some dependency in his environment, right, that is causing some inconsistency. But there are some quick start ways to get started, to answer your question, without like Docker, for example. And if you have Docker desktop, plug here, the Astronomer CLI really enables you to, in a few quick commands, get up and running. Because you still have to, with Docker, consider some of the dependency, the build process, the Docker compose, and the Astro CLI actually exposes some of that as well if you have some custom things you need to do. But happy, Nick, to go through an example of that, or if you have questions, we can definitely get you started on the CLI if you have Docker desktop. Or Podman now, actually, too.
Awesome, thanks. It's so weird how Docker did such a great job standardizing the container standard that nobody wants to use Docker anymore.
All right, any more questions for Rocco? Well, if you do, we'll still be around here for a little bit after I do the drawing. So if one comes to you and you're like, oh my gosh, now I got a question, just hang out. We will still be around for a few more minutes afterwards. I'll go ahead and do the drawing right now. But again, I want to send another round of applause to Rocco and the Astronomer crew for sending him over to do an awesome intro for Airflow. That was perfect. That's just what I wanted to see. So I really appreciate that and your guys' time you spent in coming and doing that.
Yeah, thank you for having us, Calvin. And thank you for everybody for your questions. And, I enjoy doing this. So it's great to be here.